When we enter this in, we should get the same answer. So we just take negative 311.88 times zero point 0.8 plus 888.12 times 0.2. And we notice, voila, there it is, negative 71.864 is our expected value. So it's just a little easier to do it, the value of x times its probability plus the value of x times its probability. Now, if there were a third outcome, we would calculate the same way. We would basically treat it as, okay, if there were 10 tries, then so many times this would happen, so many times this would happen, so many times the next thing would happen, divided by the total number of events that have, trials that have taken place, and we would calculate much that same way. So the only difference between the idea here and the idea of averages is that it's twofold. Number one, an average, these are really weighted averages, meaning every event it's not like a die roll. Not every outcome is equally likely. And secondly, the average that we're dealing with here is more the long run expectation. So if you know the possible values, now like in a die example, or let's say a die example, so a die is rolled, and the number of, and the number of dots is observed. Okay, well, if that's the case, then our observation variable is the number of dots that comes up. So either 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, or 6 dots can come up. Well, so each of these events, each of these valued events has, I used this is more of a formal X. I sometimes do that. So capital X and then the corresponding probabilities. So we know that 1 comes up 1/6 of the time, 2 comes up 1/6 of the time, 3 comes up 1/6 of the time, dot, 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 and all the way up to 6, which comes up 1/6 of the time. So each of these has an equally likely probability. So really, if we were finding the average here, we would add up the values and divide by 6. But this expected value approach doesn't necessitate that all of these have to be the same probability. So in this case, I could do, well, what's 1/6? 1 divided by 6 is about 0.17. So I'm going to store this value. No, I won't do that. Let's just do the value 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 of the time plus 6 comes up 1/6 of the time. And so on average, if we were to basically find the average face value, we would find that on average the number of dots would be 3.5. Now, of course, we know we can't have 3.5 dots, but that's the average number of dots that we would expect to get in the long run. So the expected value is really just a fancy type of average. The weights here are all equal weights. Generally speaking, when we're dealing with scenarios like insurance policies, there's not an equally likely chance that you do or don't get into an accident, or that you do or don't file a claim. In fact, the insurance companies know that, and they know that there's a certain likelihood of you filing a claim, so they always ensure that their expected value, it's a zero-sum situation, so your loss is their gain. So that means they make off of you roughly $71.86 per year.